Okay, so how do we, this is our quiz question, how do we, not this one, but this one, there's our quiz question. All right, so how do we find sampling rate? Again, sampling rate equals response rate. It's the same thing on your handout. And on the handout, it explains response rate. So it's just the number in the sample over what? What do we always put all these things over when we do a rate? Total, huh? It's always over, come on. It's always over total. Right, so the number in the sample over the total. So what's the number in the sample? 40 marbles drawn, right? 40 in the sample. Out of what's the total number of marbles? 300 and 500, right? The container has 800 marbles. Does that make sense? Divide that in your calculator and everything. Don't you get 0.05, which is 5%, which is B. That means they surveyed 5% of the marbles. That means the handful the kids got was 5% of all the marbles, right? So that's what we talk about, you know, when they poll what percentage of the whole population are they looking at. Is that good? Does that make sense? Be able to get that when it really counts for the big points next Tuesday, I'm hoping. Is that good? Questions? Did y'all make it through that homework okay? I guess I literally did every answer with you, but I mean, I'm hoping it's making sense though also, and not just that. All right. Well, the plan is like I said, this is the chapter that gets people a little bit, not a lot more, but a little bit more than the other ones, especially the words. Not this new one we're going to do today. It's all this kind of stuff that confuses everybody with all the words and stuff. So I'm going to move ahead. Okay, so average equals add up, divide by total, well, add up the numbers. Add up the numbers divided by the number of numbers, right? So if you add up all those numbers, all these numbers, I have no idea. Somebody have a total? I should have brought my calculator. Well, and we're going to divide by what? Was it 1, 2, 3, 4, 5, 6, 7, 8? So it's going to be negative. Most of them are negative. You've seen that they're negative, a lot of negative numbers there. So whatever that is, divide by 8. It comes out to be negative 1.8750. I want you to round to 4 decimal places. Because I'll busily doing that. I'll go grab my calculator real quick. Is that coming out okay? 6.9. I got negative 15 over 8. Is that what you guys got? Divide by 8 and whoops. And we get some Being crazy. Oops. 15 divided by 8, and I got, yep, that's right. Good on that one? Okay, let's go on. What's a median? And how's that different? Does anybody know what a median is? It's the middle. So what that means is you have to put them in order first, don't you? It's not just the middle as they sit. It's as you order them from low to high. It's the one in the middle. So yeah, let me help with that. So that we got average. Average is also called mean sometimes. So the average is the mean. Sometimes they'll use that word. But these are all kinds of averages. These are all different types of averages. So now I'm going to show you median. Median, to do that, you have to order low to high. You have to put them in order from low to high. And then, if there's an odd number of numbers, if there's an odd amount, let's just say odd amount. If there's an odd amount, take one middle number. If there's an even amount, do you realize if there's an even amount that there'll actually be two numbers in the middle? You ever thought about that? Right? We have a middle finger because we have an odd number of fingers, right? If we only had 4 fingers, we wouldn't have a middle finger. We would have 2 in the middle, wouldn't we? So whenever you have an even amount of things, there's not 1 in the middle, there's 2. So if you have an even amount, you take the 2 middle numbers and average them. So that's the way you do it. You either take the 1 middle number or the 2 middle numbers and average them. All right, so how many numbers do we have? We have 8 numbers, so we have an even amount. So we're going to have 2 numbers in the middle, aren't we? So first off, I'm going to have to order them. So here they are ordered, low to high. Now, what's the lowest number? Which one comes first? Negative 11.4. Right, that's the most negative. Followed by what? The negative 3.2s, right? Negative 3.2, negative 3.2, and then the 2 negative 1.7s. And then the negative 0.6, and the negative 0.1, and then the positive 6.9. Did I miss any? 1, 2, 3, 4, 5, 6. I got 8. So just double check, count them, make sure you got them. I got all 8. So there they are, ordered from low to high. And then let's find the median. How do we find the median? Do we have 1 number in the middle or 2?
1.
Just 1 in the middle. Oh, 2. 2. You got me going there for a minute, Cole. 2.
Making sure you're paying attention.
That's right, thanks. 2 in the middle. So which 2 are in the middle? Yeah, can you see it's these 2 right here? Because the 2 negative 1.7 is because there's 3 above and 3 below, so that's the middle. There's 3 numbers above them, 3 numbers below them. So they are together in the middle, right? So what's the average of those? Well, they're just going to be themselves. The average of the same number twice is itself. You could do it formally if you want. You could go negative 1.7 plus negative 1.7 divided by 2. I'm telling you, you're going to get negative 1.7. So negative 1.7 is the median for that one. That good? Everybody see the difference between those? Now, part C, they say, consider the data set having 1 less data point than the original set. Find the average and the median of this set. So they're going to change the data set. I'm going to go to a new screen. But go ahead and do that. So take the new data set, right? Down here in part C, they took one of the numbers out. What did they take out? The 11.4. They took out the negative 11.4. They took that out, and they want you to find the new average and the new median. right, so the average, take all these numbers, add them up. 6.9 minus 0.6 minus 3.2. This is the average. Minus 1.7 minus 1.7 minus 0.1 minus 3.2 all over, what is it, 7? And that comes out, what you guys get on, oh, the answer's right here, isn't it? Minus 0.5143. Able to get that okay? Now, let's find the median. So to find the median on that, what are we going to do? We're going to put them in order from lowest to highest. So you got to reorder from low to high. The lowest one being negative 3.2, negative 1.7, negative 1.7. I'm going to cross them off as I go. Oh, there's two negative 3.2s, huh? So I'm messing up. And then negative 0.6, negative 0.1, and 6.9. So there they are. 7 of them put in order again from lowest to highest. Everybody okay with that? Right? Everybody see why? Right? All these negative ones, right? Because negative $3.20, $1.70, 60 cents, 10 cents, positive 6.9. Good? We good there? What's the lowest? Oh no, we're supposed to find, is there 1 in the middle or 2 in the middle? Mr. Cole, what do you think this time? So 1 in the middle or 2 in the middle? 1. Yeah, because now there's an odd number of numbers, right? Now there's only, what is it, 7 numbers? Yeah, 7 numbers. So now there's only 7 numbers, right? So 7 numbers, there's 1 in the middle. Right? And who's in the middle? Well, negative 1.7 again. He's right smack in the middle. 3 numbers above him, 3 numbers below him. He's the middle. That's the median. We are done. Is that good? Those are 2 kinds of average. Technically, they're both averages, but we know in common society when they say average, they mean add them up and divide. It's technically called the mean. But average is fine. I'm not going to try to trick you or anything on the test. Average is fine. The other one is a median, is really a kind of average as well. Is that good? Is that okay on that? Put that in your 3x5 card for median and average. Hey, why do we have 2 kinds of average? Like, why do we need more than 1 kind of average? Isn't that kind of weird? You ever wonder about that? Again, the answer is no, right? No, I never wonder about that, Miss Heron. I'm not weird like you, and think about weird things like that. Well, let me give you an example, I think, that'll bring home why. Did you know, if you're thinking about career, a lot of people, they think about careers, they look at salary, right? They look at average salary. You guys ever think about being a math major? No. This is my last math class, and I'm never taking another math class again. Is that where you're at? That's fine. That is fine. If you were thinking about that, you might consider the average salary. So let me. Like if you were going in the Naval Academy, for example. What if you were going to join the Naval Academy and you pick your major, right? You can be different majors when you're going into the Navy Academy, right, at Annapolis. And isn't that where the Naval Academy is? Am I thinking right? I think so, right? Anyway, so you go to the Naval Academy. So I'm going to give you real information here. No, actually, no, this is made up, but it's basically real. It's made up. I don't know the exact numbers, but it's about what it was. The average salary of math graduates, math degree people, first year coming out of the Naval Academy was 70. Oh wait, no, I'm wrong. Was $90,000. First year out of the Naval Academy, $90,000 average salary. Okay, so if you're going to go to the Naval Academy, and you're thinking, maybe I should major in math or something, because look at that average salary coming out. Now, I'm making it up. I don't know these are exact numbers, but let me tell you, let me tell you the source of this information. Here's the actual naval, I mean, again, I'm making this up, but here could be the numbers. I'm sure they were something like this, of those who went to the Naval Academy and graduated with a math degree and got a job. These are the salaries. There they are. These are the salaries. The actual salaries. Of them, how many? Is that 8, 9 people? 9 math degree graduates from the Naval Academy. I'm just making this up. I don't know exactly what the numbers were, but it's basically the story. This was about 10 years ago. This was a salary. Was it 10? It might. It's getting old. It might be 20 years ago. That might be exaggerating. It might be 15 to 20. I don't know, something like that. About 20 years ago. That was the average salary. Now look at those averages. What do you think about? What do you think about those salaries coming out? So if you were thinking about majoring in math, and you read some brochure that said, hey, the average math salary was $90,000, graduate last year, should you expect to get $90,000? Look at these numbers again. Did this person get $90,000? 65, 67, 68, 69, they're not $90,000. 71, 71, 74, 75, they're not $90,000. What's up with that person? $250,000. So if you add those up and divide by 9, you can check it. It'll come out $90,000. So the average is 90, but is that what you should expect if you go there and get a math degree? No. This is based on a real data. Well, I got out of a book. Who's that person getting $250,000?
Some professor dude.
No, about 15 or 20 years ago, somebody went to the Naval Academy, and the NBA asked for him. And he said, no, I'm going to finish my degree in math first. He finished his math degree, and then he went to play for the Spurs. About 20 years ago. I'm looking at you, Paul. I'm expecting. You're the basketball guy, right?
Yeah.
But I'm dating you here. This is old, huh?
Yeah.
Who was the superstar for the Spurs?
Back in the day?
Yeah, that's my day you're talking about,
Yeah,
man.
back in the day.
Was he a center? Who are you thinking of?
David Robinson.
It's Robinson. Yeah, David Robinson. Yeah, he actually got a math degree from the Naval Academy. They wanted him a year early, but he said he was going to finish his degree, and then he went and played. Yeah, so his first year with his math degree, and the fact that he could shoot the basketball very well, got him $250,000. So, my point in that story is not just to goof around, but to show you how averages can be misleading. Do you see that? I mean, if you just read the average, Robinson's pulling up the average like crazy. You shouldn't expect you're going to get $90,000. If you're going to get your math degree in first year, you should expect about $70,000, right? That's really the average here, is about 70. But technically, if you add them up and divide by 9, you're going to get this $250,000 salary. I mean, it's in there, so then it comes out 90. The technical average is 90. So do you see how the average is not doing a very good job on what we want averages to do? That's why they came up with a second kind. What if you did median instead? Just put them in order. They already are in order. Grab the one in the middle. Which one's in the middle? Can you tell how many of them are? There's 9 of them. This guy right here, right? Because there's 4 before him and 4 after him, huh? He's the middle. That's a much better average for this kind of data, isn't it? If you read the brochure and it said you should expect to make about $71,000, that's the median income. That'd be true. That'd be what, on average, you should expect to make. Not 90. That's why they have a second kind of average. It depends on the data set. If you have data sets with really big numbers or super small numbers, median does a better job of giving you the middle. You guys ever watch the news or read things? They'll always say the median income. Whenever they do incomes, they go median. Or, what's the other thing always? House prices. Because in the same town, you'll have the doctors' houses that are millions of dollars, and then the rest of us, right? And if you add those up and divide, you're going to get this really whopping, the average house price in Fresno is $700,000. Well, that ain't where I'm living. right? I don't know what it is, but if they just added them and divide, that would not be truly the middle. So for, again, one more time, the data sets that have super high numbers, now not all data is that way. A lot of times adding up and dividing is a good way to go, but if you have a data set that has super high numbers, mixed in with regular numbers, adding them and dividing is not gonna really give you the middle. Median is a better kind of middle for those kind of data sets. And that's what the news always does. They'll say median house price and incomes. They always say median, which is faithful. That's right. That's the better middle. All right, so that's why we have the two kinds of average I think will be worth our time. People get confused sometimes on the median. So I've got the answers there, but try it yourself. Find the median for data set A. Can you take data set A, which is 3 through 12? So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 3 through 12. Let's find the median. Ask yourself, is there one number in the middle or two? How many numbers are up there? Count them if you're not sure. Just count them out. I don't know if there's one or two. How many numbers are up there?
Well,
10, right? Because there's 12, but you're missing 1 and 2. So that makes 10. Right? That's an easy way to figure it out. 10. There's 10 numbers. So I mean, there's 1 in the middle or 2 in the middle? 2 in the middle, yeah. So you can just kind of eyeball it. Let me see. Is it 7 and 8, I'm thinking?
yeah.
Yeah, 4 above, 4 below. Right? See how I'm sure? Because there's 4 below it, 4 above it. So 7 and 8 are the middle. So then you add them and divide by 2. It's going to come out 7.5. It's the middle of 7 and 8. 7.5. And that, indeed, is the median. That makes sense on that? Try B. So that's part A. Let's try B. Let's just do the median. The averages, I know you could all do it. Just add them and divide. Let's do B. Part B there. Let's find the median. So that's 3, 4, 5, 6, 7, 8, 9, 10, 11. Find the median. How many numbers there? Yeah, 1 through 11, but we're missing 1 and 2. So 11 take away 2. 9 numbers? 9 numbers. So is there 1 number in the middle or 2? 1, right? 9 numbers. It's odd. 1 number in the middle. You with me? And the last time we had 10 numbers, which is even. So we had 2 numbers in the middle. Good? Good. So now we have 9 numbers. So there should be 1 number in the middle. Can you tell what it is just by kind of eyeballing it? It's the 7, right? Because there's 4 below and 4 above. So 7 must be smack in the middle. So that's it. That's the median, 7. Good? Easy enough? Just grab the 1 or 2 in the middle, depending whether there's even or odd amount. And finally, this is the same thing. They just put a C next to all of them. So, same thing. Your answer just has a C next to it. I don't know why they're doing that. Doesn't matter. Just do the same thing you normally do. Put a C next to the answer. That okay? We good if I move on from that one? So let's do this. Okay. So, what are they talking about? Quiz score. What does frequency mean whenever we're doing that in these different charts? How many times, right? How frequently does that happen? How many times does that happen? So when they say quiz score 0, frequency 4, that means if this is some class and their results, that means there's 4 zeros. 4 people got a 0. And 16 people got a 10. And 14 people got a 20, and 6 people got a 30. So if I was to list them all out, and I think it will be helpful, let me do it. It's going to be 0, 0, 0, 0, 4 zeros, and then 16 tens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 tens, 14 20s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 20s, and 6 30s. 3, 4, 5, 6 30s. Look at all those. Zeros, 10s, 20s, and 30s. You don't have to do that. I wouldn't do it if I was you. But I'm teaching it, so I want to be extra crystal clear and show you how it all works, and then I'll show you how to do it without writing those out, because we don't want to do that every time. But I've tried not doing that in the past and noticed it helped students when I wrote it at least once. So that's what that means, right? That's what that big table means, is all those different numbers. Okay, so let's find the average. So do we have to add all these up and divide? You could. That'd be pretty tedious. Is there a quicker way? What are we going to do? Multiply, right, yeah. Right, because, yeah, just multiply it. Everybody getting that for the average? So for the average, yeah, you just take 0 times 4, 10 times 16, 20 times 14, and 30 times 6. Multiply them. So that's 0, 160, 280, 180, and add those up, right? Because we have 10 16s, or I'm sorry, 16 10s, and 14 20s, and 6 30s. So just multiply. Add them up. Get whatever that total is, 1622, 620, and then what are we going to do with that?
Divide by the number of frequencies.
Yeah. Divide by the total number of numbers. That's how you do average, right? You add them all up and divide by how many numbers. So for the average, I'll take 620. But now how many numbers are there? How do we figure out how many numbers there are? You just add up the frequencies, right? That's going to be what? 20, 40? 40. 40 numbers. That makes sense how we did that? Because frequency means how many. So if you add up all the frequencies, you get the total number of numbers. Divide that on your calculator, 3.5, and I guess you get the answer 15.5. Is that right? That looks a little funny to me. Yeah, I guess it is. 15.5. That okay? The frequency charts get people a lot on the exam. I want to slow down here for a minute. Does that make sense? Well, especially what we're about. Probably not this part so much. Is that good right there? You understand how to do that? Just a quick way to add them up and divide. Okay, now, what about the median? The median. How are we going to find the median? Well, let me give you a second so you can find the median. That's the one or two numbers in the middle, right? Is there one number or two numbers in the middle?
Two.
How do we know there's two? Because we have 40 numbers, right? Even amount of numbers. I'm sure I'm interrupting you as well. Okay. All right, so 40 numbers, got to be two in the middle. So how do we find the two in the middle? Well,
Could just count.
yeah, I think we better. We better get to the 20th number. It's going to actually be the 20 and 21st number. Do you realize that? Because that'll be 19 below and 19 above, won't it? Did you understand that little math I just did? Right, if you have 40 numbers, two in the middle, they're the 20th and 21st. Why? Because what's below 20? 19 numbers. What's above 21? 19 numbers. Those are the two middle. So 20 and 21. Which are the 20 and 21 numbers? Well, yeah, exactly. I'll give you the quick way and the slow way. The quick way would be to not write all these out. You don't want to do this all the time, right? And just look here. The first 4 numbers are zeros. The next 16 numbers are tens. That's 20 numbers. So the 20th number is the last 10. This must be the 20th number. How do I know that? 16 and 4. Frequency. That's how many, right? And the 21st number must be that 20. Does that make sense there? And those two are the middle, because there's 19 above them, right? And 19 below. There's 19 numbers down below 20, and there's 19 numbers above 21. So those two are the middle. So take the two middle. So I'm doing the median right now. The median is going to be the two middle numbers average. So that would be what? 10 plus 20 divided by 2, 15. That's the middle of 10 and 20. It's 15, right? We good there? Am I going too quick? Does that make sense? On that, 15 numbers. All's well? 15 is the median. All right. All right, so let me give you some percentile information. Oh, and those are quartiles. Okay, yeah, so let's do, we should do that? Yeah, no, this will be easier. Yeah, so percentile. To find the pth percentile, what do? Number one, order the numbers low to high. So put them in order, low to high. Step 2, multiply p over 100 times n, and call that L, which stands for locator. Does locator, it's an ER at the end, right? I can't spell, I'm a math teacher. Is it ER at the end? How do you spell locator? Is it locator? I thought I was just saying it weird. That is how you say it, huh? Like a locator.
Yeah.
Like an alligator. All right. Okay, so anyway, what do we do with that locator? If L is a whole number, L is a whole number, then average that number and the next number. If L is a decimal number, round L up. Round L up, even 0.1, let's say 3.1, goes to 4, for example. Up means up. Remember how we talked about earlier, there's a difference between rounding up and rounding off? We're not talking about rounding off here. We're talking about rounding up. So like 3.1 would go to 4. So if L is a decimal, round L up and take the number in that spot. Take the number in that spot. Let me correct A. I didn't say it as clearly as I could. If L is a whole number, then average that and the number in that spot. That's what I want to say. Yeah, sorry. Then average the number in that spot and the next spot. Okay. Here we go. So everybody got that down? That's real important. We're going to use that a ton of times. So has everybody got that down real clear? And I'll explain it as we're going and make sense of it because it certainly looks kind of convoluted. Cool.
Do you care if I just use my calculator to figure out the quartiles?
Do you have a quartile figurer?
It does it in your TA. 84.
Does it really?
Yeah.
I didn't know it does that.
Yeah.
Yeah, no, that's fine. You know how to do that? Feel free.
Okay.
Yeah. You can do like a data set?
Yeah, you enter the data set, and then you go to math, one bar stats, enter +1, and then it'll give out everything, like the mean,
Okay.
median.
Did you guys take a stat class or something?
Yeah.
How you know all that?
Yeah.
Nice, great, all right, feel free. Okay, so we got that down, I'll show you how that operates. So they're asking me for first quartile, third quartile, that kind of thing. First off, what are quartiles? They're like a quarter of the way through a game, right? Right. The basketball playoffs are on tonight and might wrap up tonight. So there's quarters, right? So first quarter. So if you have, let me just write the whole. Suppose you have the start and the end of the basketball game, right? And this is halftime, right? And this is the end of the first quarter, end of the third quarter, right? End of the first quarter, and this is end of the third quarter. You with me? Okay, so what do we mean by first quartile? We mean right there, into the first quarter. What do we mean by third quartile? We mean right there, into the third quarter. So we mean if you listed out all the numbers from the lowest number to the highest number, you put them all in a big list. Well, there they are. Well, they're not reordered though. You'd have to and we're going to do that in a second. We have to reorder these from lowest to highest. And then when we have them all mapped out, we want to break them into 4 even sections. And we want to know the number at the end of the first quarter and the number at the end of the third quarter. And the one in the middle is called the median. It's halfway through. So that's what we're talking about. Now, if you're at the end of the first quarter of a basketball game, or a football game for that matter, if you're at the end of the first quarter, what percentage of the game is over? 25%, right? This is P25, and this is P75. Everybody seeing those? If you're at the end of the first quarter of a game, you're 25% of the way through it. If you're at the end of the third quarter, you're 75% of the way through it. So those are P25 and P75. So they go by 2 names. Exact same spot can be called Q1, into the first quarter, or P25, 25% of the way through the game, the 25th percentile. That's what we're talking about. Catching all this? I'm giving you a lot of information all at once. Then we'll just use this for a long time. So let you copy all that down. So P25 is the 25th percentile. P75 is the 75th percentile. All right, are we ready? So let's actually do that. Now, if you got all that copied down, I'm going to go to a fresh screen. Everybody got that down? I can flash off of here. All right, let me go to fresh screen and we'll answer these questions. Okay, so they're asked. So first off, we got to reorder this data set. Oops, messed it up. Let's reorder. Reorder from low to high. So what's the lowest number? Looks like, -7, then the -4, and then and then -3. Then what? The 3, the regular 3. Notice how I cross them off as I go. You don't want to mess this up. You don't want to miss even just one number, right? So have some kind of system. Cross them off, check them off, whatever, so you don't miss anybody. 3, 4, 6, and then 3. Is it 3 7s? 1, 2, 3, yeah. Okay. And when I'm all done, I also count them to make sure I didn't miss any. These are the ways I just make sure I don't mess up. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 9, 9. Okay, looks like I got them all. Didn't miss any. There they are reordered. So that's the first thing you do for percentile or quartiles, they're called, Q1, Q3, or median, all those, you got to reorder them. You got to be put in order from low to high. So it's like looking at a football game or a basketball game. We're going to break it into 4 even parts. Well, we're going to let the formula do it for us. So here we go. They're asking for the first quartile, Q1. Into the first quarter. What? Into the first quarter, you are 25% of the way through the game, right? P25. So, how do you do it? Well, you use that little formula I gave you, which is you take P over 100 times N. So P is 25. So I'm going to take this equals 25 over 100 times N. What is N? What is N in all this chapter? Number of numbers. Yeah, N will always equal number of numbers. N is the number of numbers. How many numbers are there? Yeah, 9, huh? N is 9 numbers. So that's 25 over 100 times 9, which is, work that out, it comes out 2.25. Let me slow down there a little bit. See what I did? They're asking me for the first quartile. That means the P25, 25% of the way through the game. Put the P over 100 times N. So 25 over 100 times N, 9 numbers in my data set. So we're basically saying, hey, 9 numbers, what's 25 hundredths, 1/4, of the way through 9 numbers? Does that make sense? We're saying if you got 9 numbers, what's 25% of the way through that? Well, it's 2.25. It's 2.25. That's 25% of the way through 9 numbers. It's 2.25 numbers. Good so far? That's, now careful, that's just, if you look back here, I called that L for locator, because here's the mistake a lot of students make, is they look at that and they go, okay, that's my number. No, that's a pointer. That's a locator. He's pointing at something. So what does he point? What is it? Well, first off, is he a whole number or is he a decimal? He's decimal. What do you do for decimals? Round it up. Even like 3.1. So it's a decimal, so I got to round this up to 3. So it's not rounding off. It's not rounding to the closest. Up means up. So the next whole number up above 2.25 is 3. Right? So far so good. Now, the answer is not 3, as you can tell. The answer's over there, it's negative 3. Why? Because 3 is only a pointer. It's not saying 3, even though it says 3. It's saying third. Get the third number in the list. So if it helps, put an RD on it. What's the third number? Number 1, number 2, number 3. There you go. See, it's saying the third number in the list is 25% of the way through the data. That's what it's saying. So it's a locator. It's not the actual, it just points to the answer. It's not the answer. I keep saying that because that's what students mess up on in the test. Because they'll do all that work and they'll get the 3 and they'll think they're done. It's a pointer. It's a locator. It's saying grab the third number. That'll be your number, which happens to be negative 3. Is that good? You want to try the 75? Try the next one? The Q3, which is P75, right? Because they want the third quartile also. So try that one. Try the Q3, P75, 75% of the way through the data. Doing good. So P over 100 times N. N is 9. What is that? 27/4. It's 6.75. And round it up to 7. But it's not 7, it's 7th. Remember, that's a pointer. It's saying go grab the 7th number. That'll be 75% of the way through the data set. Is that making sense? Grab the which one's the 7th number? 1, 2, 3, 4, 5, 6. 7th number is a 7. So coincidentally, we would have got lucky if we said the 7 is actually the answer. But that's rare. That was a rare event right there. The 7th number is a 7. Is that good? Make sense how we're doing that? Okay, want to try part C? So now they do a new, I think it'd be good to practice one more. So do part C. They changed the data set a little bit. Well, they added one more data point. That's what they did. They added one more to the original data set. Looks like they put a -6 at the back. Is it cold in here? This is always, these tables feel like you could chill things on. This room is always funny. It's the state's tax dollars being well spent. Takes a lot of money to cool it down.
How did you get that 25 for the first one?
Yeah, oh, good question, yeah. Because first quartile, first quarter is P25, meaning if you're 1/4 of the way into something, you're 25% of the way in. So it's like the basketball game thing. So when you talk about a football game or a basketball game, this is the start and this is the end. Here's halftime. If I say we just finished the first quarter, that's what Q1 means, into the first quarter, aren't we at that moment 25% of the way through the game, 1/4 of the way? That is P25. So when they ask Q1, I think P25, same thing. At the end of the first quarter, I am 25% of the way through the game. So that means P25. So then Q3 is going to be P75, right? Because at the end of the third quarter, we're 75% of the way through the game. So I'm going to go to a fresh screen and do that one, see if you're getting that. Okay, so we first have to reorder. I guess you could have just used the one from last time, kind of. -7, -6, -4, -3. And then what? 3, 4, 3, 4, 6, 7, 7, 7. Did I miss any? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 numbers. 1, 2, 3, 4. And yeah, so there they are reordered. So that's the first thing, right? Don't forget that. I've always had, not always, but a couple times I've had students that do it all great, but they forget to reorder. They do all the P25, P75, and they grab. They never reorder, right? It's got to be low to high. Right? Got to put them in order first. Okay, so let's find the Q1, which is P25, right? At the end of the first quarter, you're 25% of the way through the game. So that's going to be, what, N, oh no, not N, it's P over 100 times N. So that's going to be 25 over 100 times N. What's N in this one? What's N? 10. N is 10. 10 numbers, right? 10 numbers. 1, 4, 10, 4, 5. Is it 2.5? Is that right? 1, 4, 10, 4, 5 halves, 2.5. And then what do I do with that 2.5? You round it up to 3, but 3 really means third. It's a pointer. Grab the third number. What's the third number? -4. That's how we got that. Is that making sense? Choose the third quartile. Go ahead and do the third quartile. I'll do it right now too. P75, that's N over 100, not N, I keep doing N, huh? P over 100. P over 100 times N, so 75 over 100 times N, 10 numbers. What's that, 7.5? Yeah. Round it up, 8, but not 8, 8th. The 8th number. 1, 2, 3, 4, 5, 6, 7, 8. It's a 7 again. Whoop, the wrong thing. There they are. Shouldn't have circled that. So third number, 8th number. The third number, of course, was -4, and the eighth number is a 7. And we're done. Questions on that one? Is that okay? Feel like you can do that okay? Is that making sense? You can also do that to find the median. It's the P50, 50% of the way through the data. It'll work just as well, which is sometimes easier when you have a lot of numbers. All right, let's keep moving. Okay, so question A up there. 1 through 100. So they're gonna just kind of tinker with the data set. They're all similar with slight variations, right? The first one's 1 through 100, and part B is 0 through 100. Part C is 1 through 99. Part D is 1 through 98. So you're just gonna tinker with it, and you want to see if we can handle that. So first off, the 75th percentile. Can we find the 75th percentile? Well, we don't have to reorder them. They're already in order. That's the nice thing, right? They're already in order from low to high. So go ahead, just do the formula. See what you can get there. So P75 equals P over 100 times N. It's 75 over 100 times N. What? In part A, I'm on part A right now. How many numbers are there up there?
99.
Part A? Aren't there just 100? 1 to 100?
No.
Part A?
That's 0.
Well, I'm not on part B yet.
Yeah, but 0 to 100 is 100 numbers, right? Or is that 101 numbers?
No, it's just 1 to 100? It's just 100 numbers?
Right. All right.
Yeah, just 1 to 100 is just 100 numbers.
Okay.
So that's 100 numbers. And so this just comes out 75, huh? So we don't need to round it. Remember, if it came out a decimal, we would round it up. Now, what do you do when it comes out a whole number, not a decimal? Let's look back at the instructions. One more page, right, there we go. If it's a whole number, what do you do? If it's a whole number, then average the number in that spot and the next spot. It's like taking the 2 in the middle and averaging them, you know, kind of thing. That's what you get. Everybody see the difference here. Let me hold up for just a minute. Everybody see what's going on. When you do this P over 100 times N thing, you get your locator. All the ones we've done so far have come out decimals. You just round them up, grab that number, right? But when it comes out a whole number, you take that number and the next number. The number in that spot and the next spot and average them. Kind of like when you have 2 middle numbers, you know? Right? So let's do that. So I need to take 75th and 76th numbers and average them. You get that? Because this came out a whole number. It was not a decimal. If it had been, 74.1, I would have just rounded up to 75 and grabbed the 75th number. But if it comes out a whole number, it's still a locator. The answer is not 75. It's going to be the 75th number and the 76th. What is the 75th number in this data set? Well, it's just 75. And the 76 number is just 76. Divided by 2, you're going to get 75.5, halfway between 75 and 76, which is indeed the right answer. Everybody see that? Questions I can answer on that one? How about part B, the 90th percentile? Or not part B, the rest of part A. P sub 90. So P over 100 times N. Good so far? Getting 90 there? And what do you got a whole number? So what do you do when you get a whole number for your locator instead of a decimal? You take the 90th, a whole number here. Whole number, not a decimal. So you take the 90th, it's still a locator, it's not 90, it's 90th. And 91st, which is what? The number 90, the number 91 divided by 2, 90.5. Sure enough, there it is. We good? B and C are going to be, and D are going to be a little more tricky. Well, especially B. So, we ready to move on? Is that okay? So go ahead. So try B now. B is going to be a little more tricky. Same basic idea, but a little more tricky. So try B. Okay, I'll go to fresh screen, try it with you. Okay, so part B here. So part B, where they're x in 75, so P 75. The beginning is the same. P over 100 times N. 75 over 100 times N. Well, wait a minute. Oh, what's N though? No, it's a little different actually. What's N? What's the, in set B, in set B, what's the number of numbers? 101. Is everybody good with that? Because you have 1 to 100, which is 100 plus the 0. So there's 101 numbers, huh? Everybody good that way? And so when you do that on your calculator, what's that going to be? 75.75? Which you round up, 76. No, not 76. 76th. Remember, it's a pointer. It's saying, go grab the 76th number. Well, how do you do that? How do you grab the 76th number in that list of numbers? To see how to do it? Right? If you start at 0, 1, 2, 3, 4, all the way to 98, 99, 100. What's the 76th number?
75.
Yeah. Wait, is that right? Yeah. Right, it's one below. Does everybody see that? Right? To help, if you're at all confused by that, here's what I would do. I would go first, second, third, fourth, fifth. Do you see how it's always one lower? Right? The second number is a 1. The third number is a 2. The fourth number is a 3. The fifth number is a 4. Right? First number is a 0. Right? See how it's always one below? So what's the 76th going to be? 75. See the pattern there? See how the pattern is? It's always one below. That okay? And I just grab the one number, by the way, don't I? I don't grab 2. Why am I not grabbing 2 numbers there and averaging them? Why aren't I doing that? with decimals, because it came out decimal. Remember with the locator, this came out 75.75. When it's a decimal, you round up and just grab that one number. On the last one, remember, it came out whole number. And so you take two numbers. Whole number. You take two numbers. Everybody see the difference? When you do the little p over 100 times n thing, if it comes out a whole number, you grab two numbers and average them. If it comes out a decimal, you round it up and just grab one number. Good with the game plan? All right, so try the P, whatever it is, P90. Yeah, try the P90 now. If you have not, try the P90. So P90, P over 100 times n, 90 over 100 times n. The number of numbers is 101, huh? I'm getting 90.9. Rounds up, 91st number, right? Getting kind of scribbly over there. Is that okay? 91st number. So what is the 91st number? It is 90. Right? And that data set's always one below. That good? We can probably skip C and D. It's the same kind of thing. Now that you've seen A and B. I think. Are we good with that? Questions I can answer? All well? All right, I'll keep moving. All right, particular year, total of 1,450,803 college-bound seniors took the same aptitude test. Assume that the test scores are sorted from lowest to highest, and da-da-da. Term position of the median, first quartile, third quartile. Okay, same deal. Give it a try. Oh, median. Yeah, let me do that one with you. So for median is going to be P sub what? If you're right in the middle, it's like halftime, right? What percent of the game is over at halftime? 50%. It's P50, right? It makes sense? Q1 is P25, median is P50. So just go ahead and do the P50 thing. You know, you don't have to do it the other. Remember the other way where we like listed them all? This will be a little quicker. So we've had two ways to do median. This way will be a little quicker. Just do the P50 thing for median because it's 50% of the way through the data. Should be P over 100 times N. P is 50 over 100 times N. Now what's N? What's the number of numbers? It's that 1,452,803 number, right? Oops, 803. And so, I don't know what that is. 1,452,803. Oh, definitely use calculator. I'm getting 726,401.5. Did you guys get that? 726,401.5. do about that. So it came out at decimal, didn't it? So what do you do when it comes out at decimal? Up it goes. So 726,402. Now really, TH on that. We're supposed to take the 726,402nd, or in, I guess it's ND, second number. But that's the same thing. See what they're doing on this one, guys? They're just saying determine the position. They just want the locator. So that's it. That is the locator. Right? I don't even know what these numbers are. They're just saying data value 1, data value 2, data value 3, 4, 5, all the way up to the last one, right? So I'm just saying, okay, it's the 726,402nd data value. That's all I'm supposed to do. Is that good? We good with that? And then first quartile, third quartile, that's the same thing. Can we move on from that? We okay? I'm going to move on. If you were good with that. Is that okay? Questions on that? Be the same thing? Okay, those big numbers? All right. How much? Okay, so here we are. So the first thing to do, unfortunately, is to put those in order. Got to put them in order from lowest to highest. I'm kind of hesitating here. All right, so let's do it. What's the lowest number up there?
36.
Isn't it 36? Yeah. Cross them off as you go, underline them, whatever. Do something to keep it organized. No. So, yeah, do this carefully. What's next? 52.5? And 55 maybe? Trouble seeing them on my little iPad thing. And then I guess 58. Yeah. That's the end of the 50s. And then the 60s. What's the lowest? 62? 60. Oh, there's 62 on. 60, 62, 63. 60, 62, 63, 60, 62, 63, 64, 66. Did I miss one? No, let's go 65, 68.5. 65, 68.5. 68.5 and 65. Any more 60s? No, now 70s. 71.5. 75. And 77.5. And that's it, right? That's all of them? Yeah. Double check, count them. You know, if it was my test, I would double check and count them. All right, let's move on. So there they are in order. Probably the hardest part of the problem right there. What's that? Did I mess up?
Yes, after 60.
Oh, you're right. Look at that. Thank you. Thank you. In Requeta, I got those backwards. 65. Embarrassing to be a math teacher and do that. Thanks. 66 is bigger than 65. All right. Now, what is this 5? Ready for so just go ahead and write that down, You guys all got that down? Do you want me to read it off? Is that copy down? Here, let me read it off real quick. All right? I'm just going to read it off. So 36, 42, I'm going to put them in order. 36, 42, 43.5, 47, 49, 52.5, 55, 58, 60, 62, 63, 64, 65, 66, 68.5, 71.5, 75, and 77.5. Okay, so there they are. Now, we're supposed to do this 5-number summary thing. This is really nothing new. It's just putting together what we've already done. Let me show you. So, 5-number summary. It's Q1, comma, well, here, let's just do it with P's. It's just P25. Oh, no, I'm skipping the low. Okay, let's try again. It's the low number. It's the low, then it's P25, P50, P75, and the high. There it is. That's what it is. That's what the 5-number summary is. It just means find 5 numbers. Take the lowest number in the whole data set. That'd be the 36, right? And then the P25, the P50, the P75. We've already figured out how to do that. And then the highest number in the whole data set, the 77.5. So that's all they mean by the 5-number summary. I'll show you how it summarizes the data. It basically breaks it into quarters, is what it does. So let's do that. So 5-number summary. We gotta find those 5 numbers. Okay, so what's the lowest number? That's the 36. What's the highest number? That's the 77.5. Right? Low, high in the data set. Lowest number, highest number in the data set. Now, in between, I got to find the P25, P50, P75. So let's do it. Can you find the P25? Let's start there. So P25. P over 100 times N. That's 25 over 100 times N. What's the number of, we need N, huh? We need the number of numbers. Does it say anywhere? No, we just got to count them, I guess. What is it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 18? Did you guys get 18? 18 numbers? N is 18 numbers in that list. Good so far? Good. So what do you do with that P25? It came out 4.5. Round up. Whenever you get a decimal, you round up. 5. But what do I do with that 5? Fifth. It's a locator. Exactly. 5th. Right? So we don't take a 5, we take the 5th. Exactly. So what is the fifth number? 1, 2, 3, 4, fifth number. There it is, 49. So 49 is the number a quarter of the way through the data set. It looks like it too, doesn't it? Doesn't it look like that 49 is about a quarter of the way through the data set? Right? 1/4 of the way through the data set? That's the P25. That's the end of the first quarter. That's 1/4 of the data set right there. Keep going now. So we've got the low and the high. We've got the low and the high numbers in the data set. We got the P25 number. Now find the P50 and the P75. So P50, P over 100 times N. I'm running out of room to do this problem. So P50. Over 100 times N is 50 over 100 times N is still 18 numbers. So I got 9. Did you guys get that? For the P50, so we're not done yet. But so far, right? I just did the P over 100 times N, which is for the 50, for the median, for the 50% of the way through the data. 50 over 100 times 18 comes out 9. Now, what am I supposed to do when I get a whole number? Remember? If I get a decimal like this other one here, I got a decimal 4.5. So I round up to the fifth and grab the fifth number. That's what you do when you get a decimal. You round up, grab one number. What do you do when you get a whole number answer from your P thing? 9th and 10th. Right? You grab that one and the next one. 2 numbers and average them. Remember that? So with the locator, if it comes out a decimal like 4.5, you round up and just grab that one number. If it comes out whole, you take that and the next one, the 9th and the 10th. So what is the 9th and 10th numbers? I don't know. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 60 and 62.
60.
So what's the middle of 60 and 62? 61. Right? That's what's going to come out. I mean, you can do it formally if you want to. 60 plus 62 divided by 2, it'll come out 61. So 61 is the P50. 61 is halfway through the data set. 50% of the way through the data set. Good. Now, finally, can we do the P75? So find the number 75% of the way through the data set. So I'll squeeze it in up here. P75 is 75 over 100 times 18. What is that? 13.5. So you round it up. 14th number, right? So I'm going to grab the 14th number. Everybody tracking with me? So what's that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14th number. 66 is the 14th number, the number 75% of the way through the data set. Is that good? Does everybody see how I'm doing those? Because now we have to talk about what this thing really does. We get the mechanics over. We can talk about what this thing even really is. But is everybody okay with those mechanics? Any questions I can answer on finding the P25, the P50, or the P75? So the crucial deal is when you get a decimal, round up, grab that one number, get a whole number, grab that and the next number and average them, right? Seen that a couple times now? Okay, now, what in the world is this? What is this 5-number summary thing? Well, basically, it breaks the data into 4 quarters. 5 numbers, 4 quarters. Let me go to a fresh screen here and write them out again. What was it? 36, I already forgot. 49, 61, 66, 49, 61, 66, and 77.5. 77.5. Basically, that breaks the data set into 4 sections. So if you put the data like on a number line, this would be 36. Then they have a box. This would be 49, 61, 66, and this is 77.5. It has this line going up and this line going down and a big dot there. This is called a box plot, is what it's called. And basically you take those 5 numbers and you put them on the pieces of the box like that. Let me explain what that even means. We ready? We caught up with the whole thing? Basically you put the, this is P25, P50, P75. This is the low, and this is the high, right? This is what we're writing out there. Okay, well, so what? Well, that means that this is the first quarter of the data. This is the second quarter. This is the third quarter, and this is the fourth quarter. Everybody see that? We've basically broken all the data like a football game or basketball game, broken it into 4 quarters, haven't we? Everybody see that? We've broken all the data into 4 even quarters by doing that. Now, it's kind of useless for a data set that only had, what was our original data set? 18 numbers. It's just not that important. But real life, like they want to measure like how all the high school kids just did who finished up high school on the SAT in our nation. They have like, I don't know what, 700,000 numbers. They could give 5 numbers, and that would tell you a lot about 700,000 numbers, because it would break it into 4 even sections. You would know, the worst quarter of all the kids did between 36 and 49. The next quarter, 49 to 61. The upper quarter, the third quarter, 61 to 66, and the highest quarter got between 66 and 75. You'd know something about how all those numbers are spaced out. So that's what it's useful for. That's why people like a box plot, they call it. They also call it a box and whiskers diagram. It looks like whiskers going out to the side. Those are the different names. It's a 5-number summary that leads to the box plot, right? Everybody seeing that? The 5 numbers, right? The low, the P25, the P50, the P75, and the high. Those are the 5 parts of the box. Make sense? So we can go back and look at the picture and figure out which one's right. Well, it's all messed up now. Here, I'll do a fresh screen. So you just look at that and you say, okay, it's B. See how it's B here? The low is supposed to be 36. See how that looks like it's about 36? And the left edge looks like it's just below 50, 49. The middle looks like it's right on 60, just above 60, 61. And then the right edge looks like it's about 66. And the high point is almost to 80, 77.5. That's why that's the right one. So I'm just looking at this low, and this high, where those marks are. Is that good on that? You might wonder, I would, like if I was the first thing, I'd go, why isn't this one in the green box? Why isn't it right in the middle? Because it's representing how many numbers, not just the total of the numbers. So in other words, it's saying there's the same amount of numbers from there to there as there are from there to there. Same amount of data values, I mean. Right? There's the same amount of data values between 49 and 61 as there are between 61 and 66. That's true. If you look back up here, let's go back to the original thing here. Between 49 and 61 is that many, the same amount as there are between 61 and 66. See, in both cases, there's, what is that? 1, 2, 3, 4, 5 data values? Yep, 5 data values in each section. See, that's what we're saying. We're saying how many people scored in those zones. Same amount of people scored in those zones. That's what the box chart tells you, the box plot tells you. All right, I beat that drum. Okay, so age, frequency, all this kind of stuff. All right, so we're going to do the whole frequency chart thing here. Oh, this is going to be long. 14.3, yeah. Right, okay. Okay, so age, frequency, yeah, let's try it. So, I've already got the answers there for you. So give it a try. See if you could come up with those answers. How am I getting those answers? Well, I typed in the wrong answer and the computer told me the right answer. But anyway, but how could we get the right answer to those? Do you understand what the age frequency chart means, first off? This is talking about the fire department and how old the people at the fire department are. There are 2 people. Frequency is how many, right? 2 people 22 years old. 7 people that are 24 years old. 6 people are 25, 10 or 26, etc. Looks like I'm a little too old for the fire department. So, all right, give that a try. Find the minimum, the Q1, the median. That's the 5-number summary, basically, right? So give that a try. See if you can start with the low, then do the Q1. Give that a try. I'm going to... All right, let me help. So what's the lowest number in the data set? That's the 22, right? And the highest number is the 36. The youngest fireman, the oldest fireman, right? We good? Now, how do you find the Q1? Let me help with this. So the Q1 is P25. P25, right? And which means, remember what you do. Go P over 100 times N. So P is 25 over 100 times N. Now what is N? Yeah, what's N? How do we figure out N? Add the frequencies, exactly. Is everybody tracking with me on that? This is the part that, this is where people get confused. So, remember what this chart means? Oops. Remember what this chart means? It means there's 220. So let me write it out. I'll do it one more time. It means there's 2 22s, right? And 7 24s. 3, 4, 5, 6, 7. And 6 25s. 1, 2, 3, 4, 5, 6 25s. Can I just go etc. at that point? Right? Remember, that's what it means. Right? So how many total numbers are there? Add up the frequencies, right? So let's do that. N equals the total frequencies. Because that's how many people. So that will be whatever these numbers all added up equal, which is what, 15, 25, 40, 50, 60, 79? 79 numbers, I think. Anybody else get that?
I think it's 89.
I got 79 again. Did I mess up?
I could be wrong.
79? What you got? Calculator? Okay, 79. So 79 total numbers. So that's your N. Put it up here. Boom, right there. And so then we get 19.75. Okay. Are you with me? This takes down many a student on the test. There's one just like this. Is this making sense? I'm glad to answer questions. Does that make sense? Okay, now, what do I do with that 19.75? We do when you get a decimal. Round up. And grab that one number, right? Round up. 20th. Right? Not 20, but 20th. That means you gotta start here and find the 20th number. Right? Now you could write them all out, but that'd be a big pain. Which is much easier is just to count the frequencies. There's 2 of these numbers, 2 of the 22s, then 7 24s. That's what, 9 numbers altogether so far, right? Let me go back here and write it down. Everybody see what I'm doing? So yeah, to help find the 20th number, you go, look, there's 2 22s, then there's 7 20s. That's 9 numbers. We're at the 9th number already at that point, right? And then there's 6 25s. Add 6. 9 plus 6 is what? 15, right? Now we're at the 15th number. Now there's 10 26s. That takes us all the way to the, what? 25th number. Oh, so that means the 20th number must be one of these 26s. Boom. That's the P25. Everybody see how I came up with that? I just added the frequency. There's 2 22s, 7 24s, 6 25s, add that up, and then 10 26s. Add that up, that's 25 numbers. So from the 15th number to the 25th number, those were all 26s. So the 20th number has to be among the 26s. Is that okay? You sure? That's where I get a lot of people get confused on the test. They miss that question. Makes sense? So 26. Was that the, if you can see below the writing, that is a 26. Yep, right underneath there. Yeah, so the Q1 is 26. The Q1 is 26. We're correct. Can you find the median now? So now try the median. Try the P50, right? Median's P50. See if you can do the same thing with the P50. Let me know if I can help. There's something weird with that calculation about help. So Q2, P50, P over 100 times N, 50 over 100 times N. N is the number of numbers, which is what, 79. So I'm getting 39.5, round it up, 40th. So we've got to go get the 40th number. The 40th number will be the median, the P50. Is that good? So we got to find the 40th number now, don't we? So how do we find the 40th number? Well, we go back to the frequency chart, right? You just add them as you go on the frequency chart. Here's 2, add 7, that's 9 numbers, add 6, that's 15 numbers, add 10, that's 25 numbers. I don't know if you can read that. Let me try that again. So 2, add 7, that's 9 numbers. Add 6, that's 15 numbers. Add 10, that's 25 numbers. Add 15, that's the 40th number. There we go. The 40th number is that last 27. Does everybody see that? The 40th number is that last 27. Is that good? So the 40th number is 27. Sure enough, the median, the P50, is 27. Good. Can we find the Q3 now? Is that good questions on that one? Is that making sense? This is what people always miss. So please ask me now. Try the Q3. Same kind of thing. It's going to be a little harder, a little further down the line. So find the Q3, which is into the third quarter, P75, right? Into the third quarter, 75% of the way through the data values. Okay, so Q3, P75, oops, doing that, it's P over 100 times N, so it's 75 over 100 times N. N is 18, no, not 18, 79 numbers here. So that's 75 over 100 times 79, which is 59.25. Okay, what do we do with 59.25? Round it up, 60th. So we've got to grab the 60th number. So how do we find the 60th number? Well, keep going. We're already to the 40th here, right? On my little list, I'm on the 40th. Add 12 more. This would be the 52nd number. Add 8 more. 60th. The last 29 is the 60th number. The last 29. Sure enough, Q3 is 29. We found them all. Does that make sense then, how that works? So it gets a lot of students, those little frequency charts. There's definitely a frequency chart on the exam we'll take on Tuesday. Practice exam on Monday. Is that good? Move on from that? I think we're getting close to having this done. I mean, I know we've only done 2 in this section, but those are big ones. Just kind of looking and understanding what the table means. Okay, so the purpose of this question is, do you really get what a box plot is? Like, what's that saying? Okay, look at those salaries. Look at the engineering salaries and the architecture. This is the 2 box plots, right? Starting salaries of a university's first year graduates in agricultural, in ag and in engineering. How do their salaries go? Okay, so when you look at a box plot, do you know what that means? This line, remember, this means the low. This is the high. You know, the person that made the most made what, about the highest engineer? This must be old data, because the high engineers make more than 50. The highest engineer makes more than 50,000. I think even the first year out of grad school. So anyway, of regular school. So yeah. So anyway, whatever. That's what they're saying. So the lowest paid engineer made. That's like the poverty level now, isn't it? 28,000 or something like that. Anyway, the lowest paid engineer made 27,000. The highest paid engineer made, I don't know, somewhere between 45 and 50,000. It won't be a problem as far as, spotting exact numbers. They won't ask you to do that. Okay. What does this line mean here? Which hits a little bit below 35.
First quarter.
Yeah, that's the end of the first quarter. Right? Remember, it breaks all the engineers, the same thing for the ag people, breaks all the engineers into 4 groups. Lowest group, next group, third group, fourth group. Same number of engineers in each of those sections. Right? Remember, it breaks them into even amounts of people, amounts of data values. Right? Even though the spacing is not even, there's just as many engineers that made between whatever this is, 34 and 40, between 34 and 40,000, as made between 40 and 42, because that's probably one of the most common salaries between 40 and 42. Just as many engineers made right in here as did in here, right? It's breaking them into 4 even amounts of people. All right, and then the same thing for the ag people. Okay, so here come the questions. See if you really understand this. Choose the best range for the median salary of ag. Where's the median? Where does it look like the middle of the ag salaries is? What's the middle? It's that line right here. Looks like, I don't know, a little over 30, 31. Yeah, 31 to 32. Good? Easy enough? That's that. A line in the middle is the middle. The average ag person, right? Okay. Choose the best range for the median for, oh, I need to move the screen, don't I? Okay. Goes to B. Choose the best range for the median for the engineers. Well, there it is, 40 to 41. Yeah, the middle for the engineers coming straight down. Yeah, it looks like 40 to 41. There it is. Okay, that's the middle. So the engineers, on average, made more than the ag people, right? All right, let's go back. And part C. How is the median salary for engineering majors more than the third quartile of the salaries for ag? That's a funny question. How is the median salary for engineering majors, which is right here, the average engineering salary, more than the third quartile? What's the third quartile? Yeah, you see it's right here. This is the Q3, this is Q1, Q2, right? It's the end of the third quarter of ag people, right? They're saying, how is it the middle of the engineers? The average engineer makes more than 3/4 of all the ag people. That's what they're saying, right? The engineer salary here, the middle, the average engineer salary, is more than the top, not the top, but the end of the third quarter. 3/4 of all the ag people, right? 75% of all the ag people. How is that? Well, it's just the median line for engineering is further to the right than the box is for the ag people. Now, what's this line that goes up here? What does that mean?
It's the range from Q3 to.
Yeah, exactly. That's right. This is the top, huh? Like that. That's the top. So the top quarter of all the ag people, they actually do better than the engineering people. The engineers are more stable, kind of in the middle, like that. There it is. That is, I think it's a good question to ask. Is that real life?
No.
I think it kind of is. It's been my experience.
Well, depending.
What I mean, yeah, I guess I can mean a lot of things by that. What I mean, it's funny. I don't know, when I was in school, back in the day, I graduated Cal Poly in 1993, so it's been a little while. Anyway, and we had a bunch of ag majors at Cal Poly, it's an ag school, and we had a bunch of engineers, so it's kind of, we had the groups, and all the engineering, math people like me, we think we're all smart, and we're going to make all the big bucks, and we kind of look down on the ag people. Really, there is like a little bit of a ag people, but the truth of the matter is, as you get older, you learn how life really works, and it's not like that. I mean, yeah, you do math science, you'll get a solid, good, pretty much like that. You won't get super low, but you know who gets really, really big money? Like the real top people? Yeah, so some of those ag farmers with them cows, yeah, they have my salary 5-6 times over. They would laugh at my numbers, right? Yeah, and I have a good buddy, goes to church with me. He doesn't own cows, but he sells for Family Tree Farms. Oh yeah, I'm sure his salary is double, triple mine, because he's just a great guy. Really, what I've learned since those days, if you really want to, and I'm very happy with my money, and making tons of money will not make you happy. That's another important lesson in life, but have enough to get by. But anyway, the truth is, the big money, the biggest skill to have, the skill that people will pay you for, I used to think it was being smart, No, it's being good with people. It really is. It is being good with people. Like, who makes the money? Like my buddy. Sales. He's just fabulous. You just meet him. He's just the nicest guy, and yet he's with it. He'll organize. He's got it together, and yet he's friendly. He can talk to people. Yeah, Family Tree Farms brought him over, and I don't know what it is. We don't talk salaries, but I've seen his house and his 6 children, and they're quite comfortable. So anyway, my point is funny. When I don't know, maybe I just my little nerdy world, but I just thought, oh, I'm smart. Truth is, life as it plays out. if you're good with people, people skills really is the most valuable skill. Any job you get into, even an engineer, if you're a jerk and you're all this and that, they don't care how much you know. You'll be out the back door in 2 weeks. I mean, that's the truth of the matter. It's people skills. Anyway, so this is kind of true. And ag can make the big bucks. Anyway, it's kind of funny. My daughter is an animal science major. She just got into Cal Poly. She's excited. But she was going out to Reedley this last year, and, because they have the ag stuff up there. They have all the animals and stuff like that. And she said there was this one guy in the class with them, and he wasn't the greatest at the classes, but his dad owns, like, a big cattle farm in that area, And I was kidding her. I'm always, because she always acts like she's going to marry rich because she wants horses and all this crazy stuff, And I'm like, well, honey, she's kidding. That's not really her plan. But we joke around. And I go, Emma girl, well, if you want the money, you better hook up with that. That's the wrong word, huh? Sorry. My kids have told me that's the wrong word. I didn't realize that was an inappropriate word. All right. That's not what I mean. You better get to know that ag farmer guy because he's going to be the one that's the money. And she's like, yeah, I know. And she's not really, she's like, no, he's not my type. But he all the time says, I'm going to own these. He kind of talks it up. And he's right, though. He's true. He's right. He's going to be the big money guy. Anyway. Let's see here. All right, so use the data set. Find the range. All right, so the range, you need to go from low to high. Range just simply means how far from the high to the low. So you just take high minus low, and you get the range. Just the total width of the data set. Like how broad is it from high to low. So what's the highest number in that data set? We don't have to reorder them. Yeah, looks like it is. 8. Now, minus, careful, there's a minus in the formula. And then, what's the low number? -9. So you get the double negative, add thing. And that makes sense, huh? If you're looking at a number line from 8, here's 0, -9, yeah, you would add the 8 and the 9 to get the total width, wouldn't you? And the math tells us that, right? The double negative, that's positive from your algebra days, 17. That's the range. Range just means how far from high to low, like that. All right, and then the inner quartile range. Oh yeah, we have to do that. It's just Q3 minus Q1, but we got to find them. So we do have to find Q3. Yeah, so inner quartile. Let me write that out. Interquartile. That means between the two quarters. The main quarter marks, which is Q3 and Q1. Those are the main quarter marks. So that's remember inter, when inter's on a word, it just means between the two quartiles, Q3 and Q1. It's just how wide between Q3 and Q1. So let's try that. So we're gonna have to do all the work to find the quartiles. Yeah, I don't know if I want to do all that again. So to find the quartiles, maybe I'll do this. So to find the quartiles, you're going to have to do the whole thing. We've got to reorder them from low to high. So that'd be -9, -3, -2, 1, 3, 1, 3, 6, 2 7s and a 9. Is that right? We got them all? Did I miss any? 1, 2. Oh, I missed the 8. 2 7s, and 8 and a 9, huh? Is there a 9? Did I make up the 9? There's no 9.
That was 8.
That was an 8. Yeah, that's what I'm doing wrong. I saw the -9, I guess. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right. Okay. So there they are. What's the Q1? Remember, it's P25. I'll flip through this quick. 25 over 100 times. What's the number of numbers there? Oh yeah, we just said that, huh? 100 times 9. A fourth of 9. Is that 2.25? Round it up. Third number on the list. There it is. So that's the Q1. Is that too quick? Third number in the list. P25. 25 over 100 times n is 9. 2.25. Round it up. So third number. Got it. There's the third number. And now the Q3, the P75. 75 over 100 times n. The 75 over 100 times, what is n? 9, still 9. 9/4. Wait, am I doing that right? No. I can't do that. I don't know what that is. Oops. Divided by 4, 10, 9. 6.75? 6.75, rounded up, 7th. So what's the 7th number? First, second, third, fourth, fifth, sixth, 7th is a 7. So there it is. This is the Q3. Final step. Inter, which means between, the quartiles, interquartile, Q3 minus Q1, 7 minus -2. Got the double negative thing again, right? Right, you're saying how far from 7, positive 7, to -2. From positive 7 back to -2. So that's going to be 7 plus 2. It's going to be 9. That's the width of the box if you do the box plot thing, because Q1 to Q3. You're basically finding the width of the box, called the interquartile range. That's another thing, that's the middle half of the data. Because that goes right, half the game goes from the end of the first quarter to the end of the third quarter, right? That's the middle half of the game. So you're saying 9 is the width of the middle half of the game. That's what you're doing. All right, you know all that quartile stuff.